ton. So here's our problem. A sample of acetylene gas which happens to be that, has a pressure of 7.8 kilopascals. After a certain amount of time, some of it has reacted to form gaseous benzene. And benzene happens to be C6H6. The total pressure of the mixture of gases is then, this is the total pressure we're looking at, we're going to call it PT, equals 3.9 kilopascals. Here's what we're looking for. If the volume and the temperature of the gases have not changed, so there's no change in volume or temperature, what fraction of acetylene compared to the original quantity has reacted? So that's what we're looking for. We're looking for how much acetylene has reacted from the original 7.8. So that's what we're going to work with. So first off, we should probably balance our equation here, because this reacts and eventually becomes this. So the reaction line is 6 here, you're going to need a 3 over here. So the equation is balanced. So, where do we begin? Well, we have a total pressure and we have a partial pressure, which brings to mind what is called Dalton's law. Dalton's law basically says when you mix two gases together, the total pressure, right there, will be the sum of the other pressures together. So, it would look something like this. The total pressure is equal to the pressure of acetylene in our case, so we're going to represent that with an A, plus the pressure of whatever gas you have left, and because we have benzene, and that just works out great, we're going to use a B. That's gone. Sorry about that. There's Dalton's law. So let's try to set that up with what we have. Oh, darn. 3.9 is equal to pressure of A plus pressure of B. That's what we know. And now I'm going to hand it off to our next teacher here. His name's Brian.
Hey everybody, I'm Brian. I'll explain some things. So, hopefully you understood everything that happened here. I'm just going to take this, I'm going to write it up here so we remember it. So it's 3.9 is equal to pressure A plus pressure of the benzene. So get rid of that real quick so that you can keep seeing what we're going to be doing here. Oh, don't forget that. Pressure initial is 7.8 kilopascals. Alright, so that just tells us the pressure. That doesn't really tell us the used benzene, so the moles that are used. However, we know from the universal gas law that N1 over P1 is equal to N2 over P2. That tells us that the pressure and the moles are proportional to each other. So we can substitute in this case, rather than pressure A and pressure B, we're just going to say A and B, and we're going to say that that is the mass, or the moles that we actually used. And so that'll help us be able to figure out how much of the benzene was actually used in this process. So we can state that 3.9 is equal to A plus B. So we know that that is correct, but we have two unknowns in this equation. So we're going to have to use another equation, come up with another one. Remember earlier how we balanced the equation? That 3 is going to play a big role here. So we have what we have here added up would be the total. But if we multiply the benzene by 3 right here, that would give us the total moles, or the total mass of what we had to begin with. So we have this equation. and we need a second equation. So from the chemical equation from the beginning, we understand that 3 moles of acetylene is required to make 1 mole of benzene. So we can reduplicate that backwards, and we can say that 7.8 moles will be equal to the acetylene plus 3 times the benzene that is in the same equation back here. So we multiply the benzene by 3, that gives us the original moles that we started with. So that gives us our first equation and our second equation. 2 equations, 2 unknowns, we can solve that. So we're just going to solve for A and B really quick. A is equal to B minus 3.9. Not true. 3.9 minus B. We can also say that A is equal to 7.8 minus 3B. We can set those two equal to each other. So 3.9 minus B is equal to 7.8 minus 3B. So if we added a B here, and minus 7.8 here, and minus 7.8 here, gives us a new equation of negative 2B is equal to 3.9. Negative. Divided by negative 2, divided by negative 2. B is equal to 1.95. There. We need to plug this B back into here to figure out how much of the acetylene we have left over. So I'm going to erase all this. Feel comfortable with it. B equals 1.95. We're able to say that 3.9 is equal to A plus 1.95. Minus it over, you get that A is also equal to 1.95. So that's how much acetylene is left over from the original amount. 1.95. And then that will be able to allow us to find the pressures. So I will give it back to Josh.
And I hope you all paid attention because that was some pretty crazy stuff. We did a lot of math there, but because of the relationship between the pressure of the moles, we were able to determine how much acetylene was left over from that pressure. Now, we want to know what's fraction, so we're going to make it into a percent, make it a lot easier to understand. So, we're going to take this 1.95, and we're going to subtract it from the original here, because that's what we started with. So, I'm going to erase a little bit more, just because I can. Get rid of this. So, we're taking our original amount, minus how much was left over, divided by the original amount, multiplied by 100 to give us a percent, and what do you know, it's actually super simple. It comes out as 75% dead on. That is the amount of acetylene that was used in this reaction. 75% was used to make 1 mole of benzene. So 75% of that 7.8 kilopascals was used in the reaction that it went through to create 3.9 kilopascals of benzene. I hope you all paid attention. So our goal was to find out how much acetylene was used. So we did our crazy calculations, and eventually we could solve using the relationship between moles and pressure and setting it up using Dalton's law, and then after that plugging it back into our original equation and then getting our percentage to give us 75% of acetylene was used. Thank you for your time. We hope you enjoyed our video. We've had lots of fun making it. I hope you enjoyed watching. I hope it all made sense. Subscribe. put that in there,